Okay, so to understand what we need to do for the hole sizes before we get into the pad stacks, we should talk about some what I would call maybe industry standards here. And this is using some industry standards here that are called IPC. And they're based off of three standards actually, after 7251, 2222, and 2221. Now, most of the PCB standards that we'll be following are in one of these two here. Um, and I mean, you can download these standards. I would not recommend doing it because the cheap price, which is digital, is like $135 per standard. Unless you're a member, which a member costs $1,500 a year to be a member for these standards. Um, but these are standards that a lot of industry follows. Not all of industry follows this, but it's always good to have a set of standards. And this is a common set of standards that industry does follow. So first off, the thing we have to determine in order to determine the hole size that we need to drill, we need to figure out what is the maximum lead diameter. And so I'm going to do a terrible drawing here, kind of a little perspective of like a little chip here. And then there's these little, legs. Looks like a terrible spider drawing because I put 6 leads on it. So, these are my leads here. And then these all have lead diameters. Now the thing that's a little bit odd at first that some people don't realize is that you might think that these leads are always round, but they're not always round. These are rectangular, or sometimes they're even square shaped. And so we need to know the dimensions of these. And so that's why sometimes just looking on the data sheet doesn't provide us all of the information we need. And so if we look here, if we have just a circle, the max lead diameter is pretty obvious. It's just the diameter of the circle. So it's just this diameter right here. Okay, so that's my max lead diameter. Now, if it's a rectangle, you might first state, if you remember geometry, you might say, well, rectangle doesn't have a diameter. And you're right. I mean, the only time we talk about diameters when we talk about geometry is, of course, with circles. Or half circles, well, I guess that's more radius, but with circle kinds of things. And in this case, though, we still define what we mean by the max lead diameter, and it's the diagonal of this thing. Now, if you have a rectangular pin, often this dimension is easy to find. It's this dimension that is not as easy to find all the time. But in this case, if we find these here, simple geometry, this is just using Pythagorean's theorem here. So if this is A, B, and I'll just look at this as D for diameter, well then, D is equal to the square root of A squared plus B squared. And that's just, of course, using Pythagorean's theorem. Nothing strange about that. And then for the square, you can probably guess what we've got going on here. With the square here, the diameter that we're going to define, of course, is just like in the rectangle, the diameter, the diagonal of the square. And in this case, because they're the same side here, length A on both of them, the diameter would just be A times the square root of 2 for what the max diameter is. All right, so that's going to be something we need to look at when we're looking at through-hole components. So once we have that max lead diameter, figuring out the minimum hole size is actually really easy. And so we're going to define here D, just so I don't have to constantly write it out. This is what we're going to define as my maximum lead diameter. Okay, so that's my maximum lead diameter. Now, the minimum hole size, there's actually three standards here. So my minimum hole size, min hole size, well, it depends on what level we're doing. And there's a level A hole size, which for this one, the formula is simply my maximum lead diameter, D, plus 0.25 millimeters. Level B is D plus 0.20 millimeters. And level C is equal to D plus 0.15 millimeters. Now, the difference between the levels depends on the application that it's being used in, and also not just the application it's being used in, but also the quality of the components, because if you're concerned about having any kind of variation in theirs, we need to know whether or not the manufacturing of the chips is going to be consistent with the lead diameter and pitches and things like that. So for this course, though, whenever we look at these standards, unless otherwise stated, we're going to use level A. I will still write the other standards down just because it's important to see the standards. But as I said, for this course, unless otherwise stated, these are the standards we'll be using. And this, as a side note, comes from IPC standard 2222. So that's directly from that standard. Okay, now before we move on to some other standards that we need, let's talk about what a pad stack looks like, because a pad stack takes has several things in there, and basically a pad stack is going to the main components for a through hole. So let's look at a through hole pad stack. Well, it's going to consist of kind of two circles here. And I'm going to kind of color in the outer one here. So this inner one right here, this inner circle, this is actually the hole that is drilled through the board. And that's because with through-hole components, you're really typically mounting all of these on the bottom side of the board. So you're literally drilling through the board, and then you'd be soldering on the bottom side of the board once you put the component in. Okay, so then we have here, okay, well, once I have that, then what do I do here? Well, I also have this red area, and this red area is the copper pad. And so the red area is the copper pad, and that's basically so that you actually have something to solder the lead to. And then in an actual circuit, this would then be connected up to like a trace, and the trace might, go off and do something like that. So this would be another copper trace, and it's connected off. So we not only need to, for a pad stack, we not only need to define the hole opening, but we also have to define the copper that's in here, or what we call the pad. Now, just like you might guess, there is different standards for the pad size. And so the pad diameter, and this is assuming we use circular pads. You can also use square pads or anything like that for a through-hole component. And sometimes we use a square pad to represent pin 1, for instance. We'll talk about that more later. But the standard for this, if we do the pad size, well, level A, this is my minimum hole size D plus 0.1 millimeters plus 0.60 millimeters. You might say, why don't I just say 0.7? Well, it's because of the way the standard's written, and this comes from a different standard than the 2221. So then you have level B, which, if you follow what it was for the previous standard, you can guess that these are going to be decreasing values. And these actually come from standard IPC 2221. That's where those come from. Okay. Now, of course, we'll go through an example of this once in the next video when we actually make a pad stack. And again, unless otherwise stated, for this class we're going to be using level A standard. So, before we do these standards here, let me give you a little bit of more information about level A, B, and C here, because I said it depends on the application. And so let's look at these level A. These are referred to density levels. This is general design. And this is, quote, preferred. And what this is really used for is, this is, when they say preferred, you have to, though, think about this. This is what's called low component density. Now, it doesn't mean the number of components. It means we have a lot of components in a very small area. So if we have a low component density, it means like in a given area we don't have that many components. And what does that mean? Well, it really depends on, again, the application. But typically, if you're doing hand soldering, typically you're going to hopefully try and get into this density level because it just makes it easier for the hand soldering. Then you get density level B, and as you can say, you might, this is moderate density. Now, this is really designed for automation. And so this would be for automation. So when I say preferred, I'm meaning preferred in our course here. Automation, where you're doing what's called, and we'll talk about this later on when we watch some stuff on how boards are manufactured, reflow, wave, soldering. Those reflow and wave soldering are all automation techniques. I actually used to work in this industry way back in the day. And we have density level C. And this is, of course, you can probably guess, high density. And other definitions for these density levels, yeah, there's a little bit more things here, but this is typically to give you an idea of high density levels. This is also usually, this is for like handheld / portable electronics. So for instance, a good one here is, and you're not allowed to use this if I ever ask this question on an assignment or anything, but like your cell phone is going to be something that is a high density level C there. Now this, again, for a high density, it has to be essentially automation. I mean, you can hand solder it, and there are people who are very skilled at soldering and can hand solder this stuff, but you have to have an extreme. I'm talking like you really have to be like a surgeon, and I'm not exaggerating because you have to have a really steady hand. You have to have special soldering tools and everything else like that to be able to solder high density by hand. And high density is almost never soldered by hand. It's automated, automatic soldering. Okay, so to wrap this one up here, this video, let's talk about naming conventions. And it might seem silly. And what I mean naming conventions is, okay, we've made a pad stack, so we've made one. So we've got a pad stack. Okay, but then what do we call the file name? So there is a standard for how you do this, is that you do C plus pad diameter plus hole diameter. This is for a circular pad. And if you have a square pad, which is another common one, it's S plus pad diameter plus hole diameter. And this is for a square pad. Now, this can be technically in either units of millimeters or mils. We don't ever use inches here. And let me scroll back up here. These formulas, you can convert all of these millimeters to mils. But we're going to be using millimeters for all of our pad stacks, partly because our machine that we use to etch all of our boards, the only drill bits it has are in millimeters. So why would we do mils if the only drill bits we have are in millimeters? So that's why we want to always use millimeters for our pads. Now we're going to do one additional thing here. We're going to add one additional thing here on the end. Is on both of these we're also going to do plus last name. And this is just so I don't have file conflicts when I start downloading the files to grade them. I don't want to have it where it's like, hey, you're overwriting it, because otherwise, if you're naming them correct, you should all have the same name for your file name when you turn these in. And I don't want to have to do that, so I want you to put your last name. Now, if you have a long last name, you can just put the first few letters of your last name, first 4 or 5 letters if you have a long one. I don't have a long last name, so I'll just do my whole last name. So let's just do an example of a naming convention here. So we have a circular pad, so this is an example here. We have a circular pad. And the pad diameter is 1.5 millimeters. And then the hole diameter is 0.9 millimeters. Okay, so now one thing we always do here, and it seems a little bit weird here, is we really always want to carry 2 decimal points here. So I'm going to write this as 1.50 millimeters. And I'm going to write this as 0.90 millimeters. We're always going to carry 2 decimal points. And then when we name them, we actually are going to ignore the decimal points and any leading zeros. So the way this one would be named, this pad would have, here I'll do green here, a C for circular. My pad diameter is 1.5 millimeters, which I wrote as 1.50. I ignore the decimal point, so it's 150. And then I have 0.90. I ignore the decimal point and the 0 here, and so I'd have 90. So I have C 150 90. And then technically that's all we would have for the standard, but because what I said here in our class, I'm going to add my last name, Rumsey. So that's how I would name this file. And actually, this is just automatic when you save the files, but with our pad stack editor, it would save it as a .pad file. So that's the naming convention. All right, so we're going to end this video. There's actually another video we have to talk before we actually make a pad stack, because we also have to talk about some additional layers of solder masks and paste masks.